FirstEnergy operates 20 power plants in the Northeast United States that produce nearly 70 million megawatt hours of electricity each year for over 4 million residential, commercial, and industrial customers. Over half of FirstEnergy's electricity is produced by using coal, compared to about 60% nationwide. Let's see how electricity is generated from coal by taking a virtual tour of a coal-fired power plant, similar to those operated by FirstEnergy. This plant has 3 generating units that produce more than 2,000 megawatts of electricity. At full capacity, this one power plant can produce enough electricity to supply the needs of 1.5 million homes and businesses. Generating electricity requires a fuel source. At this plant, the fuel source is coal, which arrives mainly by a barge but also by rail and truck. Each barge delivers 1,500 tons of coal, enough to keep the plant running for a couple of hours. The plant uses about 21,000 tons of coal each day, so over 1 million tons of coal is stockpiled next to the plant. A device called a stacker reclaimer scoops coal onto a quarter-mile-long conveyor that can transport up to 900 tons of coal into the plant each hour. Once inside the plant, up to a 30-hour supply of coal can be stored in bunkers. Coal moves from the bunkers to feeders to be measured and moved to pulverizers. Each generating unit has 16 coal feeders that supply 8 pulverizers. Coal enters the pulverizer and spins in a large drum, where hundreds of steel balls grind it into a fine powder. Now a fine powder, the coal leaves the pulverizers and heads to the boiler. About 335 tons of coal can be pulverized per hour. Large fans add warm air to the powdery coal and blow it into the boiler. The boiler has miles of tubes filled with high-quality water. Once inside the boiler, the coal ignites, releasing energy and generating intense heat that changes the water inside the tubes to hot, dry steam. The temperature of the steam is now about 1,000 degrees Fahrenheit. This process generates thermal energy, which is transformed to mechanical energy at the turbine, which is the next stop on our tour. High-pressure steam, now 1,000 degrees Fahrenheit at 3,500 pounds per square inch, is piped from the boiler to the first in a series of turbines. Here it expands between layers of turbine blades mounted on the turbine shaft. The steam loops back to the furnace, then onto the second turbine. In this process, the steam turns the series of turbines 3,600 revolutions per minute, providing power to the generator, the last in the series of machines. The generator continuously creates an electrical charge of 34,481 amps at 18,000 volts of electricity. From here, the electricity leaves the plant and begins its journey to customers. After the steam has been used to create electricity, it is exhausted from the turbine and sent to a condenser to be changed back into water. Inside the condenser, steam passes over the outside of pipes filled with chilled water from the cooling towers. The steam condenses to water and returns to the boilers to repeat the steam generating process over again. As the steam condenses, the chilled water inside the condenser pipes becomes warm from the heat of the steam, so it is sent to a cooling tower. These particular towers are called natural draft cooling towers, which are designed with no moving parts. Inside, the water splashes over a series of baffles, which breaks up the water into small droplets. These droplets mix with air from the open bottom of the tower, evaporating some of the water and cooling the rest by as much as 27 degrees. The newly chilled water returns to the condenser to repeat the process of cooling more steam. Since 1971, FirstEnergy has spent more than $5 billion on environmental protection. our plants are equipped with air quality control systems to remove sulfur dioxide and particulates called fly ash. Fly ash is removed by a mechanical process, and sulfur dioxide is removed with a chemical reaction using lime. These processes take place in large ductwork scrubber trains located between a unit's boiler and its chimney. Boiler gases pass through scrubbing vessels and are sprayed with slurry, a mixture of water and lime. The sulfur dioxide particles and other pollutants are absorbed by the slurry and fall to the bottom of the vessels. A fan releases the cleansed gases through the chimney. By the time this happens, more than 99% of particulates have been removed, as well as 92% of sulfur dioxide. A plant similar to this one can remove over 400,000 tons of sulfur dioxide each year. The scrubbing process creates huge amounts of a byproduct called calcium sulfite. This plant could create more than 3 million gallons of calcium sulfite slurry each day. First Energy created a process that turns that waste product into a valuable building material called gypsum, which is used to make wallboard or drywall. The slurry leaving the scrubbers is thickened and pumped through a forced oxidation gypsum or fog system. Oxygen is then added, changing it into gypsum, which is dried, treated, and sent to a gypsum manufacturer to make wallboard. First Energy recycles about 500,000 tons of gypsum each year, enough to manufacture wallboard for 70,000 new homes. Precipitators are another method of extracting coal ash, also called fly ash, which can be recycled or deposited in landfills. This mechanical process extracts fly ash left over from the combustion process. These poles, called wrappers, shake fly ash from a vibrating wire. Gas from the furnace containing fly ash flows into the box. The fly ash drops into a storage chamber and is blown into silos to be loaded into a truck. Fly ash from First Energy plants is used in manufacturing a variety of products, including concrete, grouting, roofing shingles, granules, and anti-skid road materials. First Energy also uses selective catalytic reduction technology, or SCR, to reduce nitrogen oxide emissions. SCR systems work much like a catalytic converter on a car. Flue gas containing nitrogen oxide emissions from the combustion process is mixed with ammonia. The mixed gases travel through a series of catalytic layers, which causes the nitrogen oxides to react with the ammonia. The reaction converts the nitrogen oxides to water vapor and pure nitrogen, a benign chemical that makes up 80% of the air we breathe. Both elements are returned to the environment through the station's stacks. Now that we've taken a look at how electricity is produced and some of the environmental control protection systems used at our plants, let's take a look at how the electricity is delivered to our homes and businesses. Transformers located just outside the plant boost the power from 18,000 volts to 345,000 volts, so it can travel long distances over transmission lines to where it is needed. Substations located along the path reduce the voltage so it can be moved along distribution lines attached to the utility poles. As the electricity nears customer locations, transformers on poles step down the power for use in homes and businesses. We hope you enjoyed seeing how electricity is produced at First Energy, where our energy is working for you.